to do, no?
In that book, there is a no previous year question that much not given, I think.
Yes, sir. Some are given only in the examples. Some are given.
Here you are talking about question number 16. You saying the question number 16, no? Yeah, this one. We have done this question here. Question number. This question only, now you are asking.
Three electrolytic cells containing ZnSO4, AgNO3, CuSO4.
Okay, okay. Let me do somewhere where I can copy it. And then will I be able to paste this or not? I don't know. Share whiteboard. If I will be able to paste it, then I can easily do. Can you give some idea? Can I paste the question?
Sir, I do not have very clear idea about this one, sir. I actually don't use this.
Okay, just to give 1 second. It may work. Typing is there now.
I am sir, dictating all the questions. You can ask.
Yeah. No need to dictate. It's already came. Can you see this one question?
Yes.
Yes.
Yes, sir.
So now you see this is they are saying 3 electrolytic cell A, B, C are there. Faraday's second law of electrolysis. This is based on Faraday's second law of electrolysis. Okay, if you
That the
remember this
products
one.
of electrolysis, amount of the products of electrolysis directly proportional to the amount of current passed through them.
That is the first law. You are telling this is the first law, not the second law. You tell me the second law.
Sir, that is directly proportional to the number of compounds that are present.
Directly proportional to equivalent weight. Directly proportional to equivalent weight. Amount of substance deposited on electrode is directly proportional to equivalent weight. So what we have done this one, how the formula we were using. Suppose this is W1, so it was going to
Atomic
be
mass by
E1.
number of electrons required to reduce.
W2 equal to W2 by E2. W3 by E3. This was the formula. This is the formula which we were using. And I explained you the rule to calculate the equivalent weight. How to calculate the equivalent weight? Molecular mass upon that is N
Molecular mass by
factor.
the amount, yes, N factor or the number of electrons required to reduce.
Okay. So in the first one you see ABC are there. This one is the Zn. SO4 is there. So if you are ionizing, it will give the Zn2 plus ion plus SO4 2 minus ion. This is there. Another is there AgNO3. In this one, if it is the A, this is going to be B. Here is going to be C. So this is AgNO3, right? AgNO3. If you ionize, it will give Ag plus NO3 minus ion. Another we are having CuSO4. CuSO4. If you ionize this one, passing electricity, Cu2 plus, it is going to give SO4 2 minus. SO4 2 minus. These are the ions. Little bit it is not properly working. The pen is not. Okay. Now what they are saying respectively are connected series. I study current of how much I they have said that is the 1.5 ampere. So here is 1.5 ampere the current is going to be passed through them until 1.45 gram of silver is deposited. So silver here deposition of silver is how much is there? 1.45 gram. Okay. At the cathode of the cell B. How long did the current flow? What much the copper and zinc were deposited? Okay. So now you can use this one, this equation you can see W1 E1, this is for the Zn and this is for Ag and this is for Cu. Once you can correlate this equation up to here, right? And then you can correlate the other part. So first of all, equivalent weight, you can calculate equivalent weight is equal to that is molecular mass upon what is that is N factor. So equivalent weight of Ag, equivalent weight of Ag. Okay. If you are calculating EQ of Ag, so that is what is molecular mass, it is 108 upon N factor is 1. Positive charge only 1 is there here, na? So N factor. So it is obviously it is coming 108 only. Now another one, EQ of what we are calling equivalent weight of Zn. Zn, if you are calculating 65 point how much? This is 5 something. So divided by 2, it will give some value. What the value is going? 2 3 ja 6, 2 2 ja 4, and then 32.7 something will come. 2 3 ja 6, 2 2 ja 4, that is 32.7. And next one, equivalent weight of what is that is copper. If you are calculating copper, 63.5 divided by 2. So 2 3 ja 6, 2 1 ja 2, and 31.7 will come approx. So equivalent weight got. So now from equation 1, you see this one. W1 Zn they are asking. Zn they are asking amount of Zn deposited. Even they have given, even I have calculated 32.7 equal to W2. It is already deposited. How much silver deposited? 1.45 gram. And equivalent weight of silver is 108. Now, here if you are calculating W1 equal to what will be there? 1.45 multiplied by 32 divided by how much? 108. Can you tell me how much value is coming? Hello, are you listening? 1.45 multiplied by 32 divided by 108. It is coming somewhere 0.4296 gram. Can you check your answer? That is zinc is deposition of zinc is how much? 0.4296 gram. Can you?
Let me see, sir.
Check that.
Let me see.
Please.
Question number 16. Yes.
Zinc 1, it will be 0.4296.
Let me see, sir. Actually, the solution is not given here. So
At the end of the chapter, at the end of all chapter, this will be answer will be at the end of the all chapter.
This question they have given the answers.
This will be the answer will be there. Not end of the chapter. This is end of the book. You have to see. Question number 16.
Zinc they are giving says 0.437.
For zinc,
Yes, nearly the same only.
it is 0.43. It will come approximately. Now, because we are taking the value, after decimal 1 digit now here. So that is again problem. You need to take all the digit, it will come. But okay, that much is okay. Now the another case we are going to. So let us do for the copper one, amount of copper deposition. Are you be able to understand now this one?
Yes, sir.
Okay. We have done 3-4 problem on the basis of this. You need to check the notes. You will be able to understand. Now, Sanoy, see here. So W copper upon equivalent of copper, and then we are calculating WAG upon equivalent weight of AG. So WCU we have to find out. Equivalent weight of copper we have calculated here 31.7. 31.7 equal to WAG. It is depositing 1.45. Equivalent weight of silver is 108. 108. So here is WCU if you are calculating. So 1.45 multiplied by 31.7 divided by 108. Now we have to use the calculator. You can do by your 1.45 multiplied by 31.7 divided by 108. So now 4256. 0.4256 gram. Can you check this one?
Second, 0.4256.
42. So 56. Almost correct, na?
Sir, here it is given 0.427. Almost same.
427, almost same. So this is now again one more point they are asking, Sanjay. What they are asking? How long did the current flow? So this is the time they are asking. Time. Getting my point? They are
Yes, sir.
asking the time. So I am erasing some of the portion of this one. Then we are going to do. There are no problem possibilities. Taking too much time here. Mhm. How can I take the new page? Add page. Yes. Mhm. Yes. Now, okay. Thank you. So here they are saying how long did the current flow? So they are talking about the time, right? And for the time, what we can use Q is equal to, we can use the term IT. Q is equal to IT. Now we should know the charges. Then only we can be able to use this one. Okay.
Yes.
At least, so how to do the charges? Q is equal to, we can use the formula NF.
Sure.
Uh,
Okay.
mhm. Let me. So here is the 1 mole. If you're talking about 1 mole, so one charge of 1 mole electron, charge of 1 mole electron. How much is there? 1 mole electron. This is the 96,500 coulomb. This is there. Okay. So that is, you can write that is 108 gram. That is 108 gram. That is Ag required. How much required? That is 96,500 coulomb. 1 not means 8 means what? That is the 1 mole only. And Ag, if you are writing the equation, Ag plus 1 electron. So it is going to be what? Ag1. Yes or no?
Yes.
Okay. So this much. So 1 gram Ag required, 1 gram Ag required. What will be that? 96,500 upon that is 108. This is coulomb. And in the question they have given for the silver 1.45 gram. Therefore, 1.45 gram Ag required. How much we can write? Ag required. So 1.45 multiplied by 96,500 divided by 108. 108. So this is coulomb. So how much value we are going to get? 1295.6 coulomb. This is there. Now you can use the value. Now this equation can be used. So T is equal to Q by I. Q they have given. We calculated 1295. Sorry, in a little bit different. The disturbance is 1295.6 divided by current. Here you see 1.5 ampere. So here 1.5 ampere. So if you divide this one, it is the going to give 864 second. T is equal to 154 second. Check whether you can understand or not.
Checking.
You take your time. Please understand, no? Quietly. Nothing to worry. Time is there for you. Little bit. I wrote the equation.
8 seconds. 8 seconds. Done, sir.
Can you understand this one, Sana? 8 seconds. 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 8
Yes, sir.
Okay, we have done this. One more problem I have given you. If you check your notes, you will be able to get. Okay. So can we start the next topic?
Yes, sir. Chemical kinetics.
Okay, okay, okay. Just give me 1 minute now. Let me download just the book one.
Sir, am I audible?
You are audible to me very much. I don't know. I am audible to you or not. Just 1 minute. Just downloading the file. Yeah. My geo. Just no, no, not this much. Hey God. I'm taking little bit time. What is the rate of reaction, Sanoy? Any idea? Can you give
Rate
some
of
idea
product
about
form
it?
and time taken for the reaction. A2 minus A1 by T2 minus T1.
Change in concentration of reactant or product in per unit time. That is what the rate of reaction.
Yes.
Okay.
A2 minus A1 by T2 minus T1 or T2 minus T1 by T2 minus T1.
Okay. So that we have. What is the unit of rate of reaction? Unit of rate of reaction.
Rate of reaction is
Hmm.
mole per second.
What?
Or mole per minute.
Mole per second or mole per minute or mole
Or
per
mole per
hours.
hour.
That is. Okay. It is not only mole, it is the molar, mole per liter per second, not the mole only. It is the concentration term, mole per liter per second. Getting my point?
Yes.
Huh. So it is not simply order, O or D E R. Just it's all downloaded only. Just need to share the file. The order. When we So the school teacher till now taking the online classes or the over.
Sir, that is being done only for biology, that's all. Other classes
Okay.
are offline only, sir.
Acha, acha, acha. So rate of reaction already we have done. And here if you see on your screen, you will find is anything visible to you?
Sir, what was
Is
earlier,
in,
that is only coming, sir, nothing new.
no, 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 no. That, not that one. Huh. Now can you see this one? Different file. Is it visible now?
Yes, sir, now visible.
So now we are going to study the order of reaction. What the topic is there? Order of reaction. Okay.
Yes.
So the rate expression, if you see how we can express the rate. So rate is equal to writing rate is equal to rate proportional to what is their concentration. Okay. So here how the rate law expression is there in this case, you see the rate equal to K and the K A power X B power Y. They are the reactant. These two are the reactant. If suppose A plus B, it is going to give product. So how I am writing the rate is equal to K, that is constant, rate constant. And this is the concentration of A power X and B power Y. Okay. So this is the another expression of the rate according to the rate law. So what we are going to understand from here, X and Y indicate how sensitive the rate is to the change in the concentration of A and B. So here what is there? The power is there. X and Y is the power. So if you are changing the power, if you are changing the power x and y, it will determine the rate will go either x and increasing more, so rate will increase also more. Now see, try to understand now. The sum of these exponent, that is x plus y, is giving x plus y in equation 4.1 gives the overall order of reaction, whereas x and y represent the order with respect to the reactant A and B. So if I will talk you what is the x, x is the order of the reaction with respect to A, and what is the y, order of reaction with respect to reactant B. Now you try to understand what is the order of reaction now. What is the meaning of order of reaction? The sum of power of the concentration of reactant in the rate law expression. This is the what? Rate law expression. So is called the order of that chemical reaction. What do you mean by this one, Sanoy? The sum of power of concentration of reactant. What the
That means
term we
X
are
plus
talking?
Y.
Reactant, not the product. We are using the reactant only. So here again they are saying the sum of power of concentration of reactants in the rate law expression is called order of that chemical reaction. So if you are writing this one for this particular reaction, order is equal to x plus y. Okay. Here is they are saying order of a reaction can be 0, 1, 2, 3, and even fraction. A zero order reaction means that the rate of reaction is independent of concentration of reactant. If I will talk about, it will come in detail. If anything power is going to be 0, so it is the what? Independent, because its value is going to be anything power 0 means 1. So independent of concentration. So that will come later part. So order of reaction understood. What do we mean by order of reaction? Sum of power of concentration of reactant. Is it okay? Sure. Now, if I am writing N2 plus 3H2, I will give you, here is 2NH3. This is the reaction. Okay. Now they are writing the rate. The rate is equal to, this is the K, N2, this is the power going to be 1, and H2 again going to be, power is going to be 0. So if I will ask you that is what is the order of reaction, can you tell me what will be the order?
So the order of reaction will be 1.
1. So order is equal to sum of, this is the power of concentration of reactant. Concentration of reactant. So if you see, this is the imaginary equation I wrote. So 1 plus 0 equal to, this is the 1. Okay. Now let us move out the question and you try to solve the question. Here, this is the NCERT example 4.3. So they are saying calculate, here they are saying calculate the overall order of the reaction which have the rate expression like that. Please tell me the values. What is the order of reaction? Yes
The
or no?
first one is half plus 3 by 2, so that will be like 4 by 2 or 2. First one will be 2. The second one is,
Here you are saying 2.
yes.
Okay.
One is
Hmm.
2e minus 1. That
Hmm.
means reaction order is 3 by 2 minus 1 and
Hmm.
minus 1 by 2.
Minus 1 by 2. Let us check the answer. What you are saying, whether it is correct or not. Here is the 1 by 2, not minus 1 by 2. First one is correct, second one is wrong. How you divided? 3 by 2 plus in bracket minus 1. So 3
The
by
plus
2
1,
means 1.5 minus 1. So
plus
this
1
is
by
what,
2, not
but
minus.
you said minus, or you said minus.
Might be, sir. Then I made a mistake in telling that. But so 3
Yeah.
by 2 minus 1 it would be. So sir, it will be plus 1 by.
Okay, not a problem. Okay, thank you. Here you see, Sanoy, little bit more statements are there. A balanced chemical equation never gives the true picture of the reaction takes place, since rarely a reaction get completed in one step. The reaction taking place in one step is called elementary reaction, and when the sequence of elementary reaction called the mechanism gives us the product, the reaction called the complex reaction. What do you mean by the Elementary reaction, if anybody is asking in the exam also, that is what is the complex reaction and elementary reaction. So elementary reaction, that is completing in what step? One step. Elementary reaction means the reaction which complete only in the one step, that is called elementary reaction. But when sequence of reaction, sequence of elementary reaction, if sequence of many elementary reaction join together, then it is forming the called the mechanism, gives the product. The reaction is called complex reaction. Getting? If anyone is asking elementary reaction, so the reaction is what? That is completing in single step, that is elementary reaction. But here is the sequence. If many sequence of elementary reaction are there, or the any reaction completing in more than one step, that is what is called complex reaction. Is it okay?
Okay.
Okay. Here you see, these may be conjugative reaction, oxidation. Here there, wait. Here, what there? Oxidation of ethane to CO2 and H2O passes through the series of intermediate steps in which alcohol, aldehyde, and acid are formed. So what they are saying, if you are oxidation of ethane to carbon dioxide and water, this is the series of reaction, passes through series of intermediate step, which is alcohol, aldehyde, and acid form. Reverse reaction and side reaction, that is nitration of phenol, yield orthonitrophenol and pyranitrophenol. So what they are saying, this is the example they have given, example of the complex reaction. That is, if it is the completing in the series of intermediate step, that is what is complex reaction. Now, see here, we are going for the unit. This is the important. This one is not that much of important. They have given the example only. So what is the unit of reaction? If I will ask you unit of reaction. So unit of zero order reaction or the first order reaction, or if you are going second order reaction or third order reaction, they are not going to be same. The unit is going to be different. Okay. Now I will ask you, that is zero, for zero order reaction. For zero order reaction. Here is zero order reaction. So zero order reaction, how can we write? Rate is equal to K, concentration of A, power going to be 0. So rate unit is what? Just now you told me, mole and mole upon liter. Okay. Mole per liter per second. Mole per liter per second. So what it will going to be? And K and A power is, that is going to be 1. So K is equal to, it is what is? Mole liter inverse per second. Second inverse.
So mole second per liter inverse.
It is not like that. You can this one.
So
This is
mole
like
per
that.
liter per second.
See, mole per liter, and here is what is, simply you are writing second. So again, it is going to be what? Mole per liter per second. This one. Can't you understand this?
Yes, sir.
If I will go for the second order, let us see the second order. If it is the second order, so for the second order, no, first order, not second. First of all, we are going first order. So how can we write? Rate is equal to K A power 1. So what will be there here is rate, mole per liter per second is equal to K. This is the concentration. This is what? Concentration, no? Concentration, that is mole per liter. So here we are writing mole per liter. Now, so now what will happen here? Both the mole per liter, reactant side and product side cancel out. So K is equal to second inverse. Can you understand this one?
Yes, sir.
Okay, thank you. Now, this is the second order. We are going for the second order. Second order. So rate is equal to, so now rate is equal to K A power 2. So rate is equal to, this is, we can write mole per liter per second is equal to K. Here is what will be there. Mole per liter, again, mole per liter. This mole per liter cancel out. So K is equal to, this is second inverse divided by, this is mole per liter. So K is equal to, it will be going to be liter. It will go liter then it is mole inverse, second inverse. Liter, mole inverse, second inverse. Is it okay?
Yeah. Okay.
Yes, thank
Just
you.
keep, sir, you please keep this one for 1 second. So let
Yes,
me.
yes, 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 yes. Please, please, please take your time. Done?
Yes, sir. Done.
Okay. Let us do some problem on it now. Then it will be much easy for you to understand. Now they have simplified this reaction. So can we write that is rate is equal to what we are k a power x b power y. This is the rate law. Rate law equation. Rate law equation. So if I will write you k is equal to x plus y is equal to 1, this is the order. So k is equal to rate upon a power x, b a power y. Is it okay?
Yes, sir.
Now, rate means what? Concentration upon time. Rate means what? Change in concentration upon time. This is the rate. This term is rate. And A by B. A, B is there. So 1 upon, just now we expanded this form. So 1 upon concentration power N. And N is value is what already they had 7. Sum of X plus Y. General equation they make.
Okay.
Can you understand this one? General equation, this one? Okay. Taking SI unit of concentration mole per liter. Concentration mole per liter. Time second. The unit of K of different reaction order can be calculated. So any of the reaction we will do
So you can
first of all.
scroll a bit up to the previous one.
Can I explain you separately
Completed
or what?
writing.
Can I explain you separately?
No, no, I actually you do, sir, whatever you want. So that is upon you. Sir, I did not finish writing this one. So that is why.
No, no, no. I'm asking you understood or not this one. Here the this term. This term I'm asking that you understood or not this one.
Yes, I understood. I understood.
Hmm.
Done, sir.
Done.
You can continue.
Thank you. Thank you. Thank you. Thank you. Now, see, zero order reaction just now we did now. What was there? More liter inverse, second inverse. You wrote this one correctly? Can you check?
Which one, sir? 1 liter inverse, sir.
This one, zero.
Yes, sir. Yes.
First order, second inverse.
Yes, sir.
Second order, this is mole inverse, liter, second inverse. Or we wrote like liter, mole inverse, second inverse. Is it okay?
Yes, sir.
Okay, thank you. I'm giving you the question. Yes, question number. Example 4.4 from NCRT book is there. Please let me know. Identify the reaction order from each of the following rate constant. So rate constant they have given this one, and they are asking that is you tell the order. Order. Hmm.
The first thing, liter mole inverse, second inverse. So this one is a second order. First one is second order.
Second one is this one. Second one.
Second one, sir, is given second inverse, first order.
This is the first order. But there is a way to solve also. Okay. What is the K if you are talking about K? It was the concentration upon time multiplied by 1 upon what was there? 1 upon the term was there, that is it was the concentration upon power. This is the N. Okay, N. You can check this one, not the concentration actually. Here we are going this one. Concentration power N. Na? Concentration upon time multiply by 1 upon concentration power N.
Hmm.
Okay. So we are just trying to see whether we can be just putting this one, because sometime you may forget also. K value they have given here. K value. What they have given? Liter, mole inverse, second inverse. They have given concentration. We already know mole per liter upon what is there? Time. Multiply by 1. Here is what? Mole per liter. Power, this is going to be N. Okay. So time means this is the second. Okay. You solve this one. So you will get the value of N. Getting my point? You will
Yes,
get
sir.
the value of N. So let me later mole inverse, second inverse is equal to, if I will solve this one, so it is going to be mole, liter inverse, second inverse. Is it coming? Mole, liter inverse, second inverse.
Yes, sir. Coming only.
Okay. So 1 upon mole, liter inverse, power n. Power n is equal to, this is coming, liter, mole inverse, second inverse. I'm just trying. Here is mole, liter inverse, second inverse. This is there. Anything possible to get the answer in this form? N value will come. Mole, liter, second. We cancel out. No, 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 no. Mole is not going to cancel out. Second time. It's going to cancel out. We have to put in this power, actually.
Yes, sir.
Mole. It will give the value, it will come the value 2. Now we need to just solve this one. We need to solve this value. Mole, liter inverse, this is second inverse. And I will cancel out this all the terms. This is only second can be cancel out and nothing else is going to cancel out. So just I am taking you a little bit time. Mole, liter inverse, power, this is N upon, this is what is there, liter, mole inverse. This will go, mole will go in the numerator. This is power 2. And liter will go in the numerator. Liter will go in the numerator. This will cancel out. Okay. Liter will go in the numerator. This is also going to be power 2. Because here liter, this is okay. This is okay. So, 1 by mole liter
Sir,
inverse.
will you give me one, sir, a little bit time, sir? I will go and increase the speed of the fan. It is
Okay,
running
go
very.
na, go. This is the mole inverse liter. Power going to be N is equal to liter square mole minus 2. Mole minus 2. So
Ah,
what is anything your parents are saying? Okay. So here is the mole. Okay. Liter, mole inverse power N. Now you need to see. This is again liter mole inverse power. It is going to be 2. So N is equal to 2.
equal to
Second
two.
order.
Equal to two.
Did you understand or simply you are saying?
You are just proving that is second order, so that way only.
No. You check whether
But sir,
whether the cal.
previously you already we are given the unit, so sir, this much of calculation is not required for us. We can directly
No,
go
no.
for the.
Yeah. Sometimes the in case of confusion, it is the fractional order will also be there. 3 by 2 will also come. 1 by 2 will also come. Then there is the calculation. You understood this one. This what I did.
Yes, sir. I'm writing, sir. You just keep this slide,
The-
sir.
But
I
but
won't
ki-
take
uh,
much
but
time.
but try to understand also.
Yes, sir. I
Writing
am.
is
Understand.
please check.
If I do not understand you, I will let you know.
Yeah. That I know. That I know. 1 by 2 will also come. 1 by 2 will also come. Then there is the calculation. You understood this one. This what I did. But try to understand also. Writing is please check. Please check. Yeah. That I know. If you score full marks in chemistry and other subject, your parents must be very happy.
Done.
Done. Thank you. So now let us move out the next question, Sanway. This is the solution they have given. This is representing the second order, and the another one is first order. What you said, that is absolutely correct one. So I'm not sparing much of time. Now, this is the in-text question 4.3. In-text question 4.3. Solve it, please. Solve it, please.
I'm feeling a little hot here, so can I go just change the dress, sir? I will take less than 1 minute, sir.
Please,
Here.
please, please. Go. Why you are worrying there? An instrument used for measuring area. An instrument used for measuring area. Contour mappings.
আমি তোকে বলতে বলেছি না বলবো হ্যাঁ তাই বলবি স্যান্ডো গেঞ্জি পরার কথাই বলবি যা বলবি তুমি যেখানে তোকে বলতে বলেছিলাম সেটা অনেক কম অস্বস্তি ছিল এবার ওকে বলবি আমি স্যান্ডো গেঞ্জি পরে এসেছি এটাই বলবি ওকে কোনো কথা বলার আগে আগে বল ক্যামেরা অন কর তারপর বলবি ক্যামেরা অন করবি ভয়েস অন করবি ওইভাবেই বলবি যদি অন্য থাকে তোর কল দিতে পারছে Yes, sir. Sir, I just went to wear the vest, sir, because this feeling very hot.
What is it? No problem, na? What is the problem in that? Just to solve. Just to be relaxed. Try to solve. Okay. Question 4.3. They are saying for a reaction A to B giving product. A to B giving product. The rate law given by this one. What is the order of reaction they are asking? So simply you can say order means sum of power of concentration. Sum of power of concentration. This is the in-text question. Sum of power of concentration of reactant, not product. It is the reactant in rate law expression. So 1 by 2 plus 2. This is 2.5. Or that is 2 right 1 by 2. So this is very simple now. I am giving you one more question. Yeah, this is the, again, in-text problem 4.4. This is in-text 4.4. They are saying the conversion of molecule X to Y follow the second order kinetic. X to Y. X is converting to Y. Okay. And rate they are saying rate is equal to K. And this is the X is there. This is the second order kinetic. This is the second order. This is the equation number 1. If they are talking about if, here they are saying concentration of X is increased 3 times. So here they are saying X is we are increasing 3 times. Okay, 3 times. How will it affect the rate of formation of Y? So this is the rate K 3 times, but the order is the same now, equation 2. Okay. So here, if I will mention here the initially R1 and this one I am initially R2. When you are changing the concentration 3 times, see the question they are saying X is increased 3 times. So this rate will increase also concentration you are changing that. So here is you can divide suppose you are dividing R1 divided by R2. Yeah, you can divide R2 by R1 depending on you, depending on your mood. So I am dividing R1 by R2 is equal to, this is K, X power going to be 2. Here is K, 3X power going to be 2. Now, here you see R1 by R2, R1 by R2, K cancel out. So what will be there, Sanoy? X power, X square divided by 3, 3 are 9 into again going to be X square. Yes or no? This X square and X square cancel out. So R1 by R2 is equal to 1 upon 9. 1 upon 9. So R2 is equal to 9 into R1. So 9 into R1. That is final rate. That is final rate increased 9 times to initial rate. Initial rate if concentration increased, if concentration increased 3 times, concentration increased 3 times. 3 times. Please try to understand, Sanay.
Done.
Done.
Yes.
Okay, beta. Here you can see the reaction they have given. Initially, they are talking about kx square. Then they are talking about, see, the second one, 9k square. Then they are dividing, so they are going to get the 9 times. Here the exercise question they have given 4.1 in the intake exercise question, right? Exercise question. So here they are saying from the rate expression for the following reaction, determine their order of reaction and their dimension of the rate constant. Order here is the order here if you see the second order. Second order. Yes or no? This first one. Yes or no?
Yes.
Here is there power, nothing is there means 1. Here nothing is there means 1. So 1 plus 1 is equal to, it is again going to be second order. Here is there, they are only 3 by 2. 3 by 2 means 1.5 order. This can be the fraction also. And there is the first order. Now they are asking here the, if it is the 1.5 order, see second order you already know, na?
Yes.
Liter, mole inverse, second inverse. This is there. Same will be this one also, because this is also second order now. So this will be the liter, mole inverse, second inverse. And here first order, this is second inverse only. This one, third one I am telling you now, third one. Rate is equal to, Sanoy, rate is equal to K. And here it will be, that is mole, or you can write it in this term. There is no problem. They already given now. What is they have given? CH3 CHO power 3 by 2. 3 by 2. Now see. Rate is equal to mole liter inverse second inverse is equal to K. Here is what will be there? Mole liter inverse power. What we can write? 3 by 2. We can write like this. Yes or no? Yes or no?
Yes, sir.
Okay, thank you. So we can write mole liter inverse second inverse is equal to K. Here it will be mole 3 by 2 and liter. What will be there? Minus 3 by 2. Will it be? Will it
Yes.
be?
Yes, sir.
Okay, thank you. So K is equal to, this is a mole per liter per second divided by mole 3 by 2 liter minus 3 by 2. Now we are solving. Here is mole. So mole, you see, mole here power is nothing means 1. And this will go in the numerator 1 minus 3 by 2. And then here liter. Liter already you see -1 is there. This will go in the numerator plus 3/2 and second inverse. Now you solve this one. Mole, what will come, Sanjay? -1/2 liter 2. This will go 1/2 liter 1/2 because 2 1 are 2. So 3/2. 3 minus 2 is correct one. And second inverse, this one. Can you check the answer? Mole, can you check this?
Okay.
Firstly, you try to understand, then you can check.
Seven.
Can you understand this?
Yes.
Are you sure or simply saying yes?
No, I understood, sir.
Okay. Can I explain any one of it? Total 4 are there. Do you want, should I explain any one?
Yes.
Which one?
You already explained the third one, so you can do the fourth one.
Should I do fourth one? Fourth one.
Yes, sir.
Okay. Fourth one. So they have given rate is equal to K C2H5Cl. Okay, only one term is there. So rate is equal to K, and here is what is there, C2H5Cl. Power is nothing is there, means it is the 1. So rate is equal to what? Mole. What is there? Mole per liter per second is equal to K. This is power 1. So this is what? Mole per liter. This mole per liter cancel out. So K is equal to second inverse. Check.
Same
Check.
only. Correct. Correct.
Correct. Okay, thank you. So they have given also the first one liter, mole inverse, second inverse. The second one is again liter. Third one you see liter half, mole minus half, second inverse. You got the same this one.
Yes.
Check in your notebook.
Same only, no, you
Correct.
got minus half liter, half second inverse.
Correct, na?
Yes, sir.
And this one the second inverse that already you did. Okay. This is the question. The decomposition of NH3 on platinum surface is zero order reaction. What are the rate of production of N2NH2? If if rate they have given this one 2.5 into 10 power minus 4 mole per liter per second. If rate, what is the rate of production of N2NH2? This question I need to see in the book. Let it be like that. This exercise question I need to check that one. We'll leave it this one. Here you see this question you solve 4.6. This is the exercise question, no? Exercise question. Solve this one. Will you be able to solve or should I do?
You do, sir.
Should I do?
Yes, sir.
Okay, Sanoy. Okay. I am doing. No worry. Are you in the stress or what?
No, no, sir. Nothing.
But you appears to be little bit. Okay. See, Sanoy. A reaction is second order. Okay. So if I will consider R1 is equal to, they are saying second order with reactant with respect to reactant. So if A is there somewhere, B. So R1 they are talking about with respect to reactant, it is second order. So R1 is equal to Ka square. They are saying the second order. Can you see? Will you be able to understand up to here?
Yes, sir.
How is the rate of reaction
Affect.
affected if concentration of reactant is double? If you double it. So R2 is equal to, they are saying 2A. A concentration you double, but the order of reaction is the same. This is the equation 2. So I am doing R2 divided by R1. So R2 by R1 equal to, this is the K 2A going to be square divided by K A square. Now, little bit we need to solve this one. Just a little, not more. This K cancel out. So R2 by R1 is equal to 2 2 ja 4 into, this is the A square divided by A square. So this is A square cancel out. So what is there? R2 by R1 is equal to, this is the 4. So R2 is equal to 4R1. So final rate increases 4 times to initial rate. 4 times to initial rate. 4 times to initial rate. Can you understand this?
Yes.
Okay. If concentration is doubled, can I erase?
Hmm.
Can you solve the second part, or should I do?
K square by K 2A square. R2 by
So
R1.
should I do?
Yes, you do.
Okay. So R1 is equal to the same one. K A power going to be the 2. Second order reaction is there. So this is the expression for the second order. And R2, they are talking about K reduced to half. If the reaction is reduced to half, so A by 2 power 2, equation 2. So 2 divided by 1. Yeah, you can write R2 divided by R1. So here you see R2 by R1 equal to, what we are going to do, R2 by R1. This is the K. This is the A by 2 power 2 total divided by K A square. So what is going to be, Sanoe? K cancel out, and here need to solve little bit. So R2 by R1 equal to, this is A square upon 4 into A square. So A square cancel out. So R2 by R1 is equal to 1 by 4. So what will be? Just let me erase little bit. So R2 is equal to R1 by 4. So final rate is, okay, final rate is 1 by 4th of initial rate. Initial rate, INITIAL, initial rate. Can you understand this one?
Yes, sir.
Can I erase?
Yes, sir.
Hmm. See, this is the solution they have given. One is 4 times. One is on 1 by 4 times. So the correct answer. Solve this one. Solve this one.
For a chemical reaction, you have to be.
For a chemical reaction A to B, it is found that the rate of reaction is doubled when the concentration of A is increased 4 times. What is the order of reaction? Suggest the rate law also. A chemical reaction they have given A to B. Okay. It is found that rate of reaction is double. Rate of reaction is double. So this will be become 2R. Rate of reaction is double when concentration of A is increased 4 times. A increased 4 times. What is the order of reaction? It's a little bit looking tough. They are the first, this is the equation. And this is the case one. Normal equation they have written rate law. This is the what is the rate law? Rate law. R1 rate is equal to K A power N. The case two, they are talking about the rate become 2 times when the concentration increase 4 times. 4a. This become equation 2. 2 by 1. So 2 R1 by 2 R2 by R1 if you are doing. So K 4a power n, this one. If you are solving, then n value is coming half. So order of reaction is 1 by 2. So rate is equal to K A 1 by 2. Should I do separately or you can understand?
So just you decrease the size of the slide a little bit so that I can see it at one place together.
Well,
Sir, this one. This.
is it okay?
Yes, sir. Now, okay. Just sir, please keep this like this. I'm writing.
Just you try to understand first. If you understand, then more that tomorrow is there school. Your school is there tomorrow.
Yes, sir.
Okay, then we will bind up and you can connect tomorrow as well.
Sir, in Saint Joseph school is not there tomorrow.
Tomorrow, no, school is there. Tomorrow school is there. I think in the diary they mention on 17 holiday. I don't know is there or not.
17. What is this? Ramnavami.
Ram Navami, yes. Your school
Sir,
may be
that
holiday.
must be a holiday, sir. Probably, but in our school it is holiday because sir, our school is the Hindu missionary school, no? So sir, there it is. These things are
Hmm.
there. Sir,
Hmm.
Saint Joseph is mainly Christian dominated school. I don't know what they will do.
Yes.
Done, sir.
Okay. Understood, na?
Yes, sir.
Some questions are there. This one. Now, next topic is molecularity of reaction. That we will cover in the next class, the molecularity of reaction.
Okay.
Otherwise, it will become little late. Right.
Yes, sir.
Tomorrow, if you have time, you can connect. No problem.
Which time? What time, sir?
Same time.
I will connect. Tomorrow is
Uh,
Tuesday. Yes, I will connect. Tuesday.
okay, beta. Okay.